Question 12 says point A has been reflected across the line y equals 3x minus 1. Talking about the image of point A. Verify using slope, distance, and or midpoint that the image of A is the reflection of the original point A. Okay, and to do this, what we're going to do is we're going to have to use a couple tricks here. If you remember in the investigation we did where we first learned about reflections, it had you do this drill where it had you draw a line connecting the original point to its image. So I'm going to attempt, very poorly, let me try that again, to actually draw the line that connects these two. And it's a little bit hard to do this on a tablet. Oops, you can see it's trying to do different things here. So let's see if we can get something. It's going to be horrible. Give me just a second. We'll try this again. Alright, so you should start here. And on your paper, if you're just now doing this problem, yours probably is going to look a little bit better than that. But we're trying to connect a straight line between here. If you have a straight edge or a ruler, that would be perfect. On a tablet, it's a lot to do that. But anyway, so now that we have this line, what we're going to do is we're going to actually use this particular line right here as well as the line that we were given to try and compare these two and see if we can prove that in fact that A has been reflected across. Now there's a couple things we need to prove. First, we need to prove that if it is a reflection, that this line connecting A to its image has been in fact, is in fact perpendicular to the line that it was reflected across. We also need to prove that it is an equal distance on either side. So what we can do is simply prove that this point in the middle is actually the midpoint between A and its image. Okay, between A and the reflection of A. So first off, let's prove that it's perpendicular, that is a right angle. So to do that, we are already given the equation of the line. We know that the slope, let's catch up on writing here, it's falling a little behind. And it's switching to blue on me, but that's okay. So the slope of the original line, and it keeps trying to switch colors. So of the original line, y equals 3x minus 1 is simply 3. And we know that because it's a linear equation, and the number, obviously the coefficient in front of x, is the slope. Okay, so know that the slope of the line is 3. Now if I was to look at the slope of the line that we drew connecting A to its reflection, and so we're just going to call that line we drew A to the reflection of A, can be seen by simply counting it up here. We have to go from, we can go from any 2 points. I'm actually going to go, I guess I can go from the endpoint to endpoint. So to get from the reflection of A to A itself, we are going down 2, so I'm going to write that as negative 2. And if we were to compare how we're coming across, we were coming across 6. All right. So if we think about slope, rise over run, change in y over change in x, that would mean that we have a slope of negative 2 over 6, or that reduces down to negative 1/3. Okay. Now, since these are opposite reciprocals of each other, we know, and I would suggest on a test, or anytime you're actually proving this, I'm just doing it for lack of space. I'm just going to simply make the statement that we know that perpendicular lines have slopes that are opposite reciprocals of each other. So you would probably want to write that sentence down, that they are in fact opposite reciprocals. And from that, we conclude, therefore, the lines are parallel, or excuse me, are perpendicular. So I will write that now. Perpendicular. Okay. So we have proven the first part, since they are perpendicular, that is in fact a right angle. And so we know that this line is in fact perpendicular to the original. Now we just need to prove that this point right here is in fact the midpoint. Okay. So one way we can do that is to simply figure out where the midpoint is. And a simple way to find the midpoint is something called the midpoint formula. And the midpoint formula simply says take your two x values, add them together, and divide it by 2. is basically averaging those two together. Rewrite that here. And then to take your two y values, add them together, and divide that by 2. Okay. So in this case, our two x values are -2 and +4. And our two y values are 3 and 1. 3 and 1. Okay? And it's making weird lines connecting things for some reason, but just ignore those. So if we reduce this, that becomes -2 plus 4, which is +2. And we're going to divide that by 2, so we end up getting 1. And then over here, 3 plus 1 is 4. Divide that by 2, and we get 2. So that means the midpoint of A and the reflection of A is at the coordinates 1, 2. And if we look here, in fact, if we go over 1, up 2, we end up right there at the intersection between the line we drew and the line of reflection. So it is the midpoint. So now these are in equal distance apart from the line, and we know that it's perpendicular to the line. Therefore, it is in fact the reflection of point A. Okay? So that's question number 12. We proved two things. To prove a reflection across a line, you must prove that the midpoint falls along the intersection of the line you draw and the original line. You also need to prove that in fact the lines are perpendicular to each other. And to do that, you just have to prove that the slopes are opposite reciprocals. Okay? So that means you take the 3, you flip it, it becomes 1/3, and then make it opposite, so that would be -1/3. All right? So that's question number 12.